First of all, we start by setting our time vector from -1 to 3. Then we define the equation for x1 based on figure 1a and on our earlier calculations. Next to the MATLAB figure, we can see the calculations to find the x1. Finally, we plot the signal, adding a title, x label, y label, and adjusting the line width for clarity. Next, for the rectangular signal, as illustrated in figure 1b, we follow a similar process by defining the vector within the range of -2 to 2. Subsequently, we define the equation for x2 signal based on the provided calculation. We plot the graph specifying the title, x-axis level and y-axis level for clarity. Additionally, changing the light width will make the graph clearer. These are the graphs that we obtain. The graphs are similar as in the question. Next is question number 2. We need to find ZT, that is addition of x1 and x2. After getting the equation, we need to find the time and the amplitude, and then we plot the graph. So after we do the manual calculation, we need to apply it into the MATLAB. So firstly, on the MATLAB, we define the time vector from -5 to 5 with the scale of 0.01, and then we define the x1 equation that we got from question number 1 before. And then we define also the x2 equation, x2 signal, and then we calculate the zt is equal to x1 plus x2. We define it, and then we plotting the signal by defining the subplot, plot, title, x label, and y label. Then we run the MATLAB, and the output signal is the same as the graph we obtained by manual calculation.
Task 1, part 3, we need to calculate yt using the convolution operation. First, we need to replace the t in x1t by tau, and replace the t in x2t by t minus tau, and calculate the yt by using the formula. For case 1, we consider that t plus 1 less than 0, t is less than -1. Since there are no overlapping between two signals, so the yt equals to 0. For case 2, we consider that t plus 1 is between 0 and 1, so tau is between -1 and 0. Since the overlapping between 0 and t plus 1, so we integrate from 0 to t plus 1 and we can get the result. For case 3, we consider that t is between 0 and 1, and from the graph, there is overlapping between 0 and t plus 1. Therefore, we integrate from 0 to t plus 1 for case 3. For case 4, we consider that t is between 1 and 2. From the graph, there is overlapping between t minus 1 to 2. Therefore, we integrate from t minus 1 to 2 for case 4. For case 5, we consider that t is between 2 and 3. Since there is overlapping between t minus 1 and 2, therefore we integrate from t minus 1 to 2 for case 5. For case 6, we consider that t is more than 3. Since there is no overlapping, therefore yt equal to 0. This is the coding of convolution. The result shown is the same with the calculation part. Thus, this is verified by MATLAB.
Hi, this is Joe. Today I'm going to talk about convolution in my part is task 2. So first of all, convolution is an integral that expresses the amount of overlap of one function when it is shifted over another function. And right here we can see xt equal to xt, like asterisk ht, asterisk, the asterisk is a convolution, equal to integrate x tau and ht minus tau tau. So this is the formulas for convolution. And this is the step to do when we face of this type of question. So first of all, for two functions, we let one function xt, then we replace t by tau. So we settle for our first signal. Then for the second signal, we replace ht by tau, then we do the time reversal, which is we reflect the graph on x-axis, then we get the ht minus tau, then we do the time shifting. Since the graph is start from negative infinity to positive infinity, so we move from left to the right. So it becomes like this after doing some calculations. So these are some examples for like after time shifting, time reversal, and time shifting. And consider signal move from negative infinity to the right. So now we focus on our next question. So which is ht. This is the function given. Then we sketch on this function and we get this graph on this side. This function for ht. And another function is ft, which is rect t with a unique set of multiply with a unique set function. Then we compare with the ORI equation and we get this. Then we get, so after we compare, we realize that the amplitude is 2 and the t is 1/4. Then we sketch on here. Then after we sketch on here. Then after we sketch, then we times with the unique set function, which is right here. After we time, we get this. This is our graph of the multiplication. Then we still do the same step as above. Then we change to tau. Then we do the reversal. Then we do the time shifting. Consider signal move from negative infinity to the right. So this is the overview of the whole function, and this is the function that we're going to shift from negative infinity to the right. And this is ORI function. So we consider case 1. So right here, see case 1 yt equal to 0 because no overlapping since it's less than 0 yet. So less than 0 means that it haven't reached this point. So we consider not overlapping. So when not overlapping, we don't have integration, not the area under the graph. So we integration to 0. So we consider case 2, t is greater than 0 but less than 0.25, and the graph is overlapping with some in between t to t minus 0, t minus 0.25. So integrate the area under the graph, then we get 3t. Then we leave it first, then we consider case 3 in between 0.25 and 1.5. And from the graph, we can see it overlap fully under the graph. So we integrate the area in between t and t minus 0.25. After integrate, we get 0.75. And we consider case 4, 1.5 and 1.75. Then overlap a little bit at the east side. Then we just integrate at a given time interval, then we get 5.25 minus 3t. Consider case 5 again in between 1.75 and 2. No overlapping yt equals 0 because it lies on here 1.5 and 1.75 into this is 1.75. So no overlapping means that no area at the graph, so we don't need to integrate. So consider case 6, t in between 2 and 2.25. It overlaps from positive 2 to negative 1. So this is area under the axis. So we get negative 2t plus 4. Integrate from the limits t and 2. Again, we consider case 7, t greater than 2.25 and 2.5. And this is a graph given. This area under the graph, under the axis. So we integrate from t to t minus 2.5. After the integrate, we get negative 0.5. And this negative thing later we will use in graph sketching. So consider case 8 is the last part, I think. The t is in between 2.5 and 2.75. As stated, 2.5 and 2.75. Then after the integrate, we get negative 5.5 plus 2t. Plus case 9 means that this graph, the graph just now at here, it shifted right and until the infinity side, positive infinity side, and we get no overlapping yt equals 0. So after we get how I get this yt from right here is all I get from here. This 5 positive t and this thing I get, the function. This thing I get, yeah. Then I plot in a function graph, so it shows t less than 0, t between 1.7 and 2, this is t greater than 3. Then this is a function listed right here. Then we sketch into a function graph. Sketch into a function graph. And first we see this ramp. This range is between 0.25. So right here, 3t, when it's sub t equals 0.25, we get 0.75. So which is this amplitude. So this amplitude will remain constant within the time interval 0.25 right here until 1.5, which is here. So this remain constant. This is the horizontal graph, remain as much as in between 1.5 and 0.5. Then it undergo a negative ramp, which is this one, and undergo a negative ramp in between 1.75 and 1.5. I know this is a negative. I know this is a negative ramp because we sub 1.75 inside, we get 0, and we sub 1.5 and we get 0.75 amplitude. So we know this is a negative ramp. So it undergo a 0 constant, right, 1.75, which is here, 1.75 into which is here. Then it undergo a negative ramp, which is in between 2.25 to which is right here. Just sub inside the calculation, you know whether it's a ramp, positive ramp, negative ramp, or it's a constant graph. Then this is probably a constant graph because this is only constant. So in between 2.25 to 2.5, which is right here. See, I avoided these two right here. Then last, it return to 0 because of t greater than 3. When t greater than 3, it becomes 0, so it's a constant graph.
Explain my task 2 with MATLAB code. So clear means I clear the command, CLC means I clear the data. So the t I start from 0 to 1, and the increment is 0.0001, which means each point differs with 0.0001, I will plot a point. So here F1 is a function of the step unit, which is the heavy side, and I will start from 0 and 0.25. So I have 2 step unit function. So my F3 is F1 minus F2, and my axis it will start from 0 to 0.8 for my S axis, and 0 to 2.5 for my Y axis. So if I run it, we will see the graph will perform like this. So now going to the task about my second input signal. So now I'm here to plotting this given functions. So the same, I'm using the heavy side, which means I'm using the step unique step function. So 1 is 0, 1.5, and so on. So the last, I will get this output signal. So the same thing, I will start from 0 to 3 for Y axis, S axis, negative 1.2 to 1.8 for my Y axis. So if I run it, I'll get this input signal for HT. So after I have make sure the 2 signals are correct. So we will going to do our convolution. So the above this 16 line is the I just copy and paste from this code and this code, so I can produce 2 input signal. So now I'm here to start my convolution. So here I'm start from F3 and H7, which means I convolution my F3 and H2, which means F3 times HT, and 0.001, I will plot a point. So these functions, T convolutions, will equal to linear space and these functions, which means I'm here to adjust the time vector length. So here means I will start my point, and I will plot until my graph, my signal n, and this is my length y, which means how many points I'm going to plot. So the same thing, this is the function name that I given in T convolution. So the x-axis label and y-axis label and the title. So if I run it, I can get this graph. So comparing with my manual calculation, this I getting the same result with my manual calculations and the simulations of MATLAB. So which means that our calculation is correct. So that's all for me. Thank you.